D and E are different from the other questions we have encountered. And this is from question 18, so it's a little bit more tricky perhaps than ones that are previous in the textbook, but nevertheless, they are good examples to demonstrate how to solve this. Now, what makes this different is that prior to this, we were given a value that we needed to work out the probability for. In this one, we are given a probability and we need to work out the value. So in D, we're going to work out K such that, that's what ST stands for, the probability of X less than K is equal to 0.2. And then E is a bit different again. I'll get to that in a second. This one's not too bad. So this is kind of in a diagram form. I have my probability distribution. This is still question 18. So I've got a mean of 10, a standard deviation of 0.5. K is somewhere. Now, I can see that K is equal to 0.2, and that tells me that K must be down here somewhere. I wonder why. It's because I know that the area under this curve on the left-hand side is 0.5, and the area on this side of the curve is 0.5 because the normal distribution is symmetrical. Because I know it's symmetrical, and this side is 0.5, then 0.2 must represent a value of K below 10. So I know that K is below 10. I just don't know exactly what it is. Okay, so we are looking for this, and we are told that the area is 0.2. Okay, so that's our diagram done. Now let's do the solution itself. Really simple. In our calculator, we are going to go to Menu, Probability. This should be familiar by now, Distributions. And we're going to use this one here, which is the inverse normal. Inverse normal asks for an area instead of a probability. Why does it say area, not probability? Well, because it is in fact the same thing. If you remember that this graph here is the graph of the probability distribution function, and that the area under the curve represents the probability at point K, or at point 10, or at point 11, etc. Okay, so when it asks for the area, it's simply asking you to put in the probability that you're given. So we type in 0.2. The mean is 10 and the standard deviation is 0.5. That is given to us in the question. So click on OK. I'm told that that value must be 9.57. So therefore, I'm writing this down. Of course, you can't see it. Is equal to 9.5792. There we go. I've gone to a few decimal places. So there's my answer there, 9.5792. And if I go back to my textbook and we look at the answer here, we can see it's 9.5792, and hooray for me, I've actually got the number of decimal places correct. Okay, let's have a look at E. Now, E is sandwiched between two values here. So X is between C1 and C2, and the probability under the curve, the area under the curve, is 0.95. The probability is 0.95. The area under the curve is 0.95. Okay, what does that mean? Now, I'm going to make one assumption here. And I'm going to assume that C1 and C2 are symmetrical about the mean. In other words, the distance from the mean to C1 is the same as the distance from the mean to C2. Otherwise, it's going to be a bit tricky for me to answer this. So I'll do it diagrammatically first, because that way I get a sense of what's going on. And so if I draw this up with my mean of 10, then C1 is going to be down here somewhere. I can see that the probability is 0.95, so I know it's pretty much most of the curve. Should have been symmetrical. My drawing's not that great. And I know that this here is 0.95. So that's 0.95, like so. Now we need to break this down a little bit. How do I work that out? Well, I know that if this is 0.95 here, then I know that this bit here and this bit here must be the other 5%, the other 0.05. And more importantly, because it's symmetrical, I know that that must be 2.5%, right? So 0.025. And this bit here must be also 0.025, like so. So that's good. So that means that I can basically use my 0.025s to figure out what C1 and C2 is. So I can say that the probability that C1 is less than X would have to be 0.025. So I'm using the facts here and my diagram to come up with something that I know my calculator can solve. My calculator can solve that. Okay, so away I go into my calculator. And I go, again, I can copy it if I want to, but I might do that in a second to show you that it can be done, but I'll just go the long way for a second. Probability, distributions, inverse normal. The area in this case is 0.025. Double checking my numbers that I've got them right. The mean is 10. The standard deviation is 0.5. And I press OK. And I get 9.02 and a bunch of other decimal places there. So I think I'll leave that as 9.02. I'm just going to write that down before returning to my screen. Okay, so the probability of C1 equals 0.025 means that C1 is equal to 9.02. Okay, and similarly, we can go to the probability of C2 less than X is equal to, well, what value would that be? You can do it in two ways. You can say it's going to be 100% minus 0.025, or you can simply say that it is 0.95 plus another 0.25. So you could do that as well. So 1 minus 0.025, which equals 0.975 is the way I would do it. I'm just running out of room here, so I'll go here, and I can say, therefore, C2 is equal to, okay, off to our calculator, and away we go. This time I'll use my arrow keys just to make it a little bit faster, maybe. Press enter. That brings it up again. Now I'm going to use my arrow keys and change the 0.025 to 0.975. Like so, and that gives me 10.98. 10.98. Okay, so switching back, there's my two values. That's all it asked me for, but I guess I could say i.e. 9.02 is less than X is less than 10.98. And we'll check our answer to make sure. 9.02 and 10.98. So that is basically it. So that's how you work out a value given a probability.